All right, 9. Oh, I really like number 9. This is a real kind of... All right, so we're given this force versus time graph. Those of you that asked about it, did anybody get... Those of you that asked about it, was the only issue decimals?
Yeah.
The horizontal axis is milliseconds.
Oh. Yeah.
Is that the only problem? Does anybody still want me to go over it despite that? Yes? Okay. All right. So the graph shows an approximate plot of force magnitude F versus time during the collision of a 0.058 kilogram superball. Don't forget to convert grams to kilograms. The initial velocity of the ball is 34 meters a second. Perpendicular to the wall, and then it rebounds directly back the way it came from. So our final velocity has to be the same thing, but negative, right? Cool? And the question wants to know what the maximum force was from the wall. Okay? Well, if this horizontal axis is time, what's the concept that connects this given information to this graph? What's the relationship between those two things? What do you got?
Change in momentum is the integral of force over time.
Good. Change in momentum is the integral of force versus time, right? In other words, the area of this should equal our change in momentum, right? Follow? So, find your change in momentum. That's going to be mass times Vf minus Vi. So whatever 86 times 0.058 is. So it gives you negative 4.988, which I guess we could probably just call negative 5, don't you think? Kilogram meters a second. Everybody cool with that? All right, so now we need to write an expression for the area of this mess. So I don't know how you guys went about this. I can never remember the trapezoid area. I always just break it up into triangles. What is it? Half of base? How did I get that?
68. The bottom plus the top over 2 times something or something.
Yeah, we'll come back to that in a second. Sorry. It's Vf minus Vi is negative 68 times 0.058, right?
Yeah, that's 3.
Oh, I did, no. Oh, I did 86 instead of 68. Sorry, a little dyslexia. Thank you, sorry. 0.058 times 68. Sorry. All right, everybody good? Yes. Yeah, totally. So yeah, I think that's probably the easiest thing to do. What Carla just said is take this area and use it to fill in this area, right? And then it just becomes F max times whatever this t here is. And looking at the graph tells us it's 4 milliseconds. So F max times 4 milliseconds has got to equal that. Cool? So the milliseconds is 0.0004 seconds. And it looks like I chose my sign convention wrong, right?
I think it's 2.
Man, I am struggling today, you guys. More than usual today, though, which is saying something. Okay, so are we good here? So the only thing I notice is there's no way this can work, because if you solve it, you're going to get a negative force. And it's clearly positive, which just tells me I must have chosen my sign convention backwards, right? I made my velocity decreasing, but a positive force wouldn't make that happen. So I should have made my VI negative and my VF positive. Now, does that really matter? No, I would just ignore the negatives. Yes?
I don't think it's important, but it doesn't really say what force it is. So couldn't it be the force on the wall from this Super Bowl, like.
Oh, right. Yeah. So Dan's question is, are we finding the force from the wall on the Super Ball or the force on the Super Ball from the wall? Let's see.
If it's a positive force.
Yeah, why am I dumb? Oh, here's number 9. Yeah, it just says the force during the collision. It doesn't say which one it is. Yeah, so, yeah. Okay, are we good? All right, so that was number 9. Last but not least, numero 11. Ah, yes. I like this one. All right, so here's what we know for number 11. Yes.